Hey guys, and welcome back to another video in this week's Basic Algorithms in Java tutorial. So, like I promised, we're going to be coding up our custom comparators. And remember our cookie business sales, where we're going to be comparing the customers that this time are not just me, and me. They'll actually be real customers. So, I believe we talked a lot about custom comparators. Just to rehash, we are going to compare instances of a class. So let's go ahead and jump right in. Again, this is kind of a continuation of last video, so I highly suggest you go watch last video if you haven't already. There's also kind of a fun story, so I would highly suggest that. Now, what happened to my rep bullet? Why does things look different now? All right, I have 126 unnamed repls. Good to know, Sunny. Maybe you should start naming your repls, but this time I'm not going to name my repl. Okay, so we have our REPL, and so since we talked about how custom comparators are used to compare objects of defined classes, well, in order to compare objects of defined classes, we need to create a defined class, right? Obviously, duh. So since we're talking about my cookie business, which is thriving, by the way, we're going to create a customer class. Oh, I cannot spell today, can I? Customer.java. And so this should be, we've seen this quite a bit, public class customer. And then in our class, there are a few things that I want to do. I want to be able to, and I'll go back and show you guys this once before we go start typing on our own. We would like to create some variables. Now, these variables are ultimately what they are going to be comparing. So are you comparing, in this case, a student? You're going to compare their name, age, ID. This is a constructor, very important to make our life easier when we start initializing our data. And these functions are very important because they tell our comparator, what do we compare? How do we compare? How do we grab these values? So yeah, otherwise though, everything is rather simple. There's not overcomplicated logic or code. It does look a little long though. So let's go ahead and jump right in. Let me go ahead and do this. So create variables first, variables. Then we're going to create a constructor. Then we are going to create functions used in comparators. Alrighty, so for our variables, of course, we need a string called name because I would love to know the name of the sweet people who are buying my cookies, even if they're burnt on the bottom. We love you for buying our cookies. Then we need to give an age. Now, if we think about this, why might the age, I really like age for some reason because I feel like this directly applies to real life. Why might age be important? Because I'm almost positive that if we dig down deep in our Crumble Cookies database or Great American Cookies database, there must be somewhere that analyzes how old people are and what taste they prefer. Or like say maybe people from ages 21 to 30 really enjoy this particular flavor, while people from ages 50 through 60 enjoy a different flavor. I bet you there is something in there. Maybe I'll get a job at Crumble one day just to find out. Okay, so that's why I particularly enjoy age. What is something else that people might ask for? This is another integer, or like we could do public double, I guess. Public double cost. How much do people spend on average? Or how much maybe do these people, as you get more complicated, how much do these age ranges spend usually? Do younger people spend more? Do older people spend more? These are all good questions that I'm sure companies are asking themselves. So we've created our variables, and the next step that we want to do is create the constructor. Why? Because constructors make our life so easy so that when we create the object in the main class later, boom, it is done really quickly. So we're going to say, we're going to create a constructor, public customer, and then we're going to take in a string called name, an integer called age, a double called cost. And we're going to set it equal to, we're going to say this dot name, which is this variable here, is equal to whatever we pass in this parameter. This dot name is equal to name, this dot age is equal to age, this dot cost is equal to cost. There we go. Constructor, check. Okay, so we've created our constructor to initialize our values. Last but not least, I'm just going to create my functions over here that simply just return this variable. Easy, easy, easy peasy. Public string, right? I blinked on a second. I was like, what are those texts called? Public string get name. We're going to return this dot name. Public int get age. Return this dot age. Public double. Scroll down a little bit. Get cost. Return this dot cost. Okay, so we have our variables, our constructor, and our functions. Again, you might be asking us why we need these functions, and the reason why we need our functions is because that way, when we create our comparator later in our main function, we have a function to tell it how to compare. Because later our comparator is going to ask us, well, what am I comparing, Sunny? What am I comparing in your customers? Well, I'm going to compare, go ahead and get the name and we're going to compare the name. Or go ahead and get the age and we'll compare the age. Get the cost and we'll compare the cost. So the whole point of these functions is to grab the value from the instance. That way we can compare all those different values. Capiche, capoche. I forgot nobody really replies to me when I'm on Zoom. So capiche, capoche, I have to say it myself. All right. So this is our customer. We've defined our class. So we've defined the class. The next step that we're going to do is we're going to create objects of the class. Now, this, we're going to create a function for it for the sake of simplicity, because I don't want to get into all these details of us having to create new functions just to add in these people. We're going to create one function, hard code these people into the program, and then use these people. So one thing I want to show you really quickly, I called this function my init data function, like initializing my data. All I've done is I've created a few students here. In that case, students, because our example was students. This case will have customer, right? Customer name is equal to new customer with their name, their age, and their cost, right? This is classic creating your instances. Now I have students.add here. And what this is since we're comparing instances, we need to have a data type that will save our instances. We can't expect our instances to just float around. So we create a list. Now I don't have a picture of the list quite yet, do I? Do I? No, I don't. Very funny. I feel like I should probably find a list for you guys to see just to show you guys a quick example. So let me go ahead and do that really fast and I'll pull it up for you. Hey guys, so I found the example I was looking for. I really wanted to show you guys a visual because it's kind of hard to explain this when we haven't really done something similar. But like I was talking about, we create a list that is going to save our instances. Now notice that previously in our list that we worked with, they save a data type. Well, this time we're not saving a data type because we're not saving strings or integers. We're saving instances. So this is going to be a class. Why? Because this list is composed of students. So in our case, we'll have a list we'll have a list created out of customers. Another thing I want to note, two more things that I want to note. Most importantly, where is our list in this example? Our list isn't in the main function. It is in the main class, but kind of hovering between the main class and the main function. So that means we have to add the keyword static in front of it just because this isn't in our main class right now. That's one thing to note. Second thing to note, lists cannot implement themselves. They have to implement something else. In this case, we're implementing an array list. So that's just another thing to make a note of. Again, import java.util.star. So back to what we were doing, we wanted to initialize our data, right? But before we initialize our data, since we're going to end up adding our instances into a list, we're going to go ahead and create our list. So in between the main function, but still above the main, still in the main class, we're going to create static list of what? List of customers. And then we're going to call our list customers. I spelled that wrong, didn't I? I was like looking at it. I was like, that doesn't look quite right. Customers is equal to new array list. There we go. Now I do have to import stuff. Otherwise it will give me errors like it just did. And I spelled customers wrong here too, customer. Notice how this is singular because customer refers to this customer, and then customers over here is the name of our list. So all I have to do now is import java.util.star, and then all these red lines should go away. Wonderful. So we've created our list. Now we need to go save the list. We create a function called init data in here. Static void init data. Now, notice how when I created my function, it's not in the main function, but it's still in the main class. So we created static void. We're just going to create some very basic students now here. Okay, so we're going to have, or not students, sorry, customers. I can add public in here like I did in the example so that everything is matching. So we're going to say customer. What should we name our customer? Let's see, I feel like somebody who likes cookies, Susie. You know, I feel like Susie's the type of person who would like curl up on a couch and buy cookies and bake cookies. Just gives me Susie vibes. Is equal to new customer. And that new customer's name is Susie. And she is, I feel like Susie's kind of like a middle-aged name. I'll say 56. And she spent $50.45 today because she bought some for her family. And then we're going to add her to the customers list. So customers.add Susie. Done. There we go. One person has been added. I'm going to repeat this 2 more times because I'm going to add 2 more customers here. Susie has been such a loyal customer of mine. Ever since she found out about my company, she's just been buying food from me every week. At this point, she's going to go bankrupt, but I'm not going to tell her that. All right, another one. I feel like Joe is also one, but I feel like Joe might be more elderly. So let's say he's like 87. Wow. Pretty, 87 should go here because 87 is the age. And let's say Joe is just living with him and his wife. So they only spend $30.22 buying cookies. And his name is Joe, and we have to add Joe here. Last but not least, I want to add a teenager. So actually, let's go ahead and add Sunny because, of course, why wouldn't I buy for me? Sunny honestly isn't buying anything. She's just hungry. Let's pretend that Sunny is like 23. She is a hungry post-college person who is broke, so she's not going to pay herself anything. She's just going to take the cookies and go, right? And then we add Sunny to our list. So now that we have the people in our function, they haven't done anything. These values so far haven't really been added into our list yet. Why? Because we need to go into our main function and actually physically run this code first. We need to run the function. So run init data. And after this, now all of these customers have been added to the list. So once we do init data, this is where the real magic comes in. We're going to go ahead and we are going to, let's use this one. We're going to use and sort it by its name. And so students.sort. Well, the first one is your list name. In this case, it would be customers. So we'd say customers.sort, capital C, comparator.comparing. And then I'm going to give your class name, which in this case is customer, and then 2 colons and give it the function. Notice how get name is not something we've made up. Get name is exactly what we made in this function here because it returns the name. So see how everything is connecting together? We created a function called getName so that when we use our comparator, whoops, it's over here. So that when we use our comparator, we're able to get the name and use it to compare. The for each loop is just used to print out the values once they have been sorted. So shall we try it out? Yes, we shall. Sort by name. All right, so we're going to say customers.sort and comparator.comparing. And then we're going to say sort a customer, obviously, and sort them by their name. We do not need parentheses. Is the last time I checked that? Yes. And so after this line here, the customers have been sorted by their name, but I need to print it out. So for customer X in customer, no, that is not how we wanted to do it. In customers, system.out.println X. Why do I have an odd feeling about this? Let's run it and see. Now it should give us the names sorted. How are they sorted? Well, they are, oh no, what happened here? Hold on, this is not supposed to give us customer tags here. It's supposed to give us the actual name. So let me go ahead and check back here really quickly. Right, x.name. I missed that tiny part. X.name. Why? Because X is just simply customer. This person is the person with the correct first name, but we need to actually get their name because we can't tell with these IDs here. So we grab their name and then we print it out and it's going to give us Joe, Sunny, Susie. Well, this is alphabetical, as you can tell. Reason being is that we didn't specify how we wanted to sort it, but since name is a string, generically, and by default, it will sort it alphabetically. So we're going to do the same thing for a couple other ones because I want to show you guys how we can sort our, instead of get name, we still have two other functions to use. We can use get age and get cost. So get age, and over here, we're going to change it to get cost. There is something that we do have to change though. We don't need to, we still print x.name here because no matter what's happening, I still want to print out the name instead of anything else. I don't need to know how much they spend or how old they are when I print out my values. I just need to know who they are. So then I run my code. I feel like I should go like this, system.out.println, and then print out dashes so you guys can actually see the difference here. Now, integers sort from least to greatest by default, and since we haven't told it anything else, it's going to sort from least to greatest. So we start off with the first part, alphabetical, Joe, Sunny, Susie, which is correct. Then Sunny, Susie, Joe. Why? Because from least to greatest, Sunny is the youngest, and then Susie, and then Joe. And then again, when we sort the last one, we sorted it by cost. Sunny didn't pay anything. Sunny is cheap. Just kidding. Sunny is running her own shop. She didn't pay anything. Then Joe paid the second least, and then Susie paid the most, right? So yeah, guys, we finished. That was a lot, wasn't it? I kind of feel like I was rushing through that. Maybe I talked too fast, but I feel like time-wise, it did take a lot of time. So I probably didn't talk that fast. Okay. So, custom comparators. And trust me, this is probably one of the most real life simulating that I've seen in a while because, well, you know, real companies probably do this. They probably sort you by your age range and how much you pay and things like that, right? So this is something that is very useful and it's not that complicated once we truly understand what everything's going on. So that was week 2 of basic algorithms in Java. I hope you guys enjoyed it. I love telling my cookie story to you, and I hope I will see you guys next week. So I'll see you then. Bye, guys.